Hello everyone, welcome to video 7 of my GenAI series. Today we are going to learn about something very interesting, which is LLM Gateway Pattern. Let's think of a scenario that you have 6 teams and 6 teams are having 6 different LLM use case. So one team is getting throttled request in production, but whereas other team is getting more costs, and there is no service which is monitoring the LLM use across teams. Here's what LLM Gateway comes into picture. So LLM gateways are a service layer where I put an LLM gateway. It can throttle, it can do rate limiting, it can do cost calculation, it can do routing and all those stuff, so that it is monitored at a central place and everything works fine. I will be showing the LLM gateway configuration as well as how it is used in real production scenario. So without wasting time, let's get started. First I will show you guys the problem which we face. So let's say every team talks to the AI provider on its own. So nobody can tell the full cost and nothing stops one team from making a mistake. A gateway puts one gatekeeper in front of everyone. So the problem is like this: team A calls provider A API, team B calls also provider A API, team C calls provider B API, team D calls provider A API. There is wrong model, low limit, and it can happen anywhere. So once we solve this problem, how it looks is we have a gatekeeper which is LLM gateway. Now team A, B, C or D can define their providers here and it can call provider A, B or C. And in LLM gateway we would have rate limiting, model routing, audit logging, cost tracking, fallback chains and PII masking. So the gateway is the single doorway. Every AI call goes through it. You see what's happening, control it and switch AI models later without changing the app code. So now we can think that what are the guardrails, right, that LLM gateway puts. So first guardrail is model routing. What it does is, in case of a small, we can have like a simple task, right, small simple task, then fast model. If it's a hard task, then a large and powerful model. Live traffic and test traffic, that takes separate path. So first one is model routing. Second one is rate limiting. A cap per team, per user, per minute or hour or day, that we can configure. Then fallback chains. So if we are using best model, we can have faster backup model, last save answers, and then switches automatically if a call times out or get throttled. So it can happen that one LLM is not working, but we still have our system working with fallback LLMs. And cost tracking is also important, which is done in the LLM gateway, that it counts what every call cost per team, per model and sends a warning before anyone overspends. Also audit logging, it records every prompt and then it records the uses of it. It also checks the PYI data and everything that can be passed to a compliance unit. And then PYI masking, so it removes PYI after logging, it can remove also, it masks. Now we will see the gateway endpoint actually in code. This is a sample code, LlmGatewayController.java, and we have messages endpoint. And here what we do is, in the gateway we first do rate limit check, then we can mask the PYI before it leaves your network, then we route to correct model, then we call the LLM, then we calculate the latency also, and here we track our cost, we can do audit logging and everything. So this is how it is done in the code, and this code basically resides in LLM gateway. And every request carries an XTeam ID header, that's the unit rate limits. Cost tracking and audit logs are all keyed on, so that every teams can be segregated by this header. So these are just whatever I have talked about, 1, 2, 3, 4 points. And then we will come to routing and rate limiting. So this is where we have per team control, which a model team gets, and how many requests they are allowed both depend on the team ID. A team's own rule wins over general default. So this is the model router which we were using in the last code, and in the model router we do have teams. These are the team name here we can define and the model for that team, and then we can also have like switch cases depending on team ID, team limits, and various configuration we can switch the models. And any team without an explicit entry in team limits gets some default request per minute. It is safe, but with explicit limit it will call the switch statement and then select the model accordingly. So this is the routing layer. Now we can check the fallback chains. So fallback chains is, let's say if a particular model is failing, then we will try other models, and if every model fails, fail back to the most recent similar cached response instead of erroring out. So we can write the fallback chain, we can have the fallback models, and then when we call with fallback, we can call that LLM chat with that with every model, and if we get an exception, we can basically catch this exception and say that trying next. So it will try all the models, and let's say if all model fails, then it will get the cached result. So this is what I have explained. So the most important thing here is the learning. The learning in LLM Gateway is we have to operate AI. We don't have to just use it like a normal person. So LLM Gateway is one doorway. Every AI call goes through it. We get cost visibility, rate control, and whatever we have discussed like the audit trail, model swaps, and everything. None of which you get by default when we don't use LLM Gateway. Now 6 guardrails are there in one control plane, that also we learned in LLM Gateway, and 3 is we have to build this before the mess happens, not after. So this is something which we should build before building our production system and use it as a gateway for all our production LLM calls.